how to find the area of a shaded region. If you have two or more functions, you can sort of have this region that's bound by them. And let's just say I have my points on the x-axis from A to B. And I have this function that looks something like that. And then I have maybe another function. And this one's f of x, and this one's g of x. And I wanted to find from where x is A to where x is B, this area in between them. The way I'm going to do this is I'm going to use the formula, and I'm going to remember that it's always going to be the upper minus the lower function. So I always write it out, and I say, all right, that's going to equal, the area is going to equal the integral from A to B. So from here to here of whatever the upper region is minus the lower region dx, because it's from x to x here. But the real way that you write this is just my way of remembering, but the real way that you're going to write this is, I'll write it here. Oh, where can I put it here? The area is going to equal the integral from A to B of f of x, because that's the upper one, it's the one on top, minus g of x, because that's the lower one beneath, dx. And if you have this in terms of y, you're going to have to change things up. Oh, okay. And in this case, what you would have is it g of y and f of y. So that means we're talking about points on the y being where you're going from. So let's say this is A and this is B now. And I have functions that look something like this. And now I want to find the area from A to B that's bound by these two. And in this case, you're always going to take it's going to be the area is going to equal the integral from A to B of the right function, the one on the right, minus the one on the left. And that's dy. So that means it's always going to be the one on the right minus the one on the left. So in this case, it's f of y. I'm sorry, this should be y, and this should be y. Minus g of y dy. So let's just go ahead and, actually I want to say one more thing. Graph, graph, graph. You have to graph these to know which one's the upper and which one's the lower, or which one's the, well, mainly the upper and lower. Okay, I also want to say that you might see it say, find the area of the region, which is how I set it to begin with. But that's the same thing as saying, find the area bounded by, and then that's the same thing as saying, find the area enclosed by. Those are some different ways that they'll say this. So you either see area of the region, area bounded by, or area enclosed by. So let's take a look at some examples. Let's say I said, find the area bound by or bounded by these two functions. Y equals x squared and y equals square root of x. So if I graph these, well, I know that if I have y equals x squared, let's use a different color. Let's say I have y equals x squared. I know it's going to look something like this. And then if I had the other graph, this one here, and this goes up this way too, but this one doesn't. Y equals square root of x. And that would look something like that. I notice that they do cross here. And if I did this like on a Desmos calculator or a graphing calculator, they would cross right here at x equals 1. So my x's are from 0 to 1. So to find this, I'm going to remember what I said. And actually, this is x squared, and f of x equals, actually, I won't even say what it is. I'll say y, because I don't want you to think f of x for the formula. So I'm going to say y equals x squared and y equals square root of x. And I know that is going to be the integral from a to b of the upper function minus the lower dx. So the upper function here, you might think it's y equals x squared, maybe because I wrote it first, maybe because you just think that that's going to give you more positive numbers. But if you look at the graph, this is actually the upper function. And this is underneath, so this is the lower function. So that means it's going to be the area, it's going to be the integral from a to b of the square root of x, because that's the upper one, minus x squared dx. And instead of from a to b, I should be putting, because I see that they cross at 0 and 1. So I'm going to put 0 and 1. So if I integrate this, I'm going to get that the area is equal to, now this would be 1/2, then you would add, and then you would go ahead and divide it, and then that would give you 2/3 x to the 3/2 minus 1/3 x from 0 to 1. And once you do all the work there, you're going to end up with 1/3 for your answer. And I'll show you real fast how we got to this. I just need room. So I'm going to erase this graph and I'll work it out. If you already know how to do it, you can just fast forward to the next example. So we'll go from here. The area was equal to so the first thing you do is plug in 1. So that's going to equal 2/3 times 1 minus 1/3 times 1. And then you're going to plug in 0. But then you're going to have 0 here and 0 here. So you'll have minus, because you always subtract, and then minus nothing. So you end up with 2/3 minus 1/3, which gives you 1/3 for the area. All right, let's work on another example. So I'm going to do these two. X is equal to y squared minus 1. Hold on. And x is equal to 1 minus y squared. Now, I know what these look like, but I'm going to take you to Desmos so that we can try and do it there. So I'm here in Desmos, and I know that it was x is equal to 1 minus y to the second power. And there's that graph. And then I'm going to come down here and put x is equal to y to the second power minus 1. Now I can just use this right here to figure out what, because I need a and b, because now these are kind of side by side. They're not one on top of the other, and it's x is equal to something. So I could just use Desmos and know, but there could be a time where you don't know what your a and b are, because now if we're looking at the x-axis or the y-axis to see what a and b are. So if you don't know, or the calculator doesn't show it to you well, you go back to the whiteboard, then you're going to set those two equations equal to each other, because then that's when you want to know where they cross, and that's where we were looking at. So I would go, all right, y squared minus 1, when does that equal 1 minus y squared? When does that equal 1 minus y squared? So in this case, I'd minus y squared minus, no, let's add y squared to both sides. That way I can just, so I'm going to plus y squared here, plus y squared here, and that would give me 2y squared is equal to 1. You could do it the other way too, I just didn't want to mess with the negative. And then that gives me y squared is equal to 1. And then I would take the square root of both sides, and so y would equal square root of 1, which is plus or minus 1. So you know that that was plus or minus 1 was where they were crossing. So that would be A would be -1 and B would be 1. And then you would go ahead and take your antiderivatives from here. So back on the Desmos, I can see which one's on the left and which one's on the right. So this one in red here was y squared minus 1. So that's this red one. If you're colorblind, I'm pointing to it right here. So that's x equals 1 minus y squared. And this blue one here, I'm sorry. Yeah. So the blue one here is y squared minus 1. So at this point, the blue one is on the left, y squared minus 1 is on the left, and 1 minus y squared, this is talking about in this region, okay, where it's bound by. So x equals 1 minus y squared is on the right, because that's where we're talking about this region. What happens? This is the left, this is the right. So according to the formula, it's the integral of the one that's on the right minus the one that's on the left. So let's go back to the board. Actually, I should just work on that. So remember how we said this. We said that it's going to be the integral from A to B of whatever's on the right minus whatever's on the left, dy. So right comes first, left comes second. And then you got this one over here. So this integral is going to look like this. The integral from A to B, this is the area of 1 minus y squared minus y squared minus 1 dy. So I would just go ahead and clean this up and get the negative through, and I would have 1 minus y squared minus y squared, because of this minus, plus 1 dy. So then that area is going to be the area of 2 minus 2y squared, and the antiderivative of 2, oops, is 2y, and that's y to the 1 over 1, so there's nothing there. And then this is going to be minus, and this is going to be 3, so it'll be 2/3 y. And you're going to evaluate that from -1 to 1, because we found that. And once you do that, you're sorry, I'm just looking. Okay, so this, let me get a different color, is gonna end up, I'm gonna work it out over here. And that's gonna end up being, oops. Here we go. All right. That's gonna end up being, the area is equal, I'm working from here now, and I'm gonna go ahead and plug in 2 times 1 minus 2 times 1 to the third over 3 minus 2 times negative 1 minus 2 times negative 1 to the third over 3. Let's get some room. All right, so how did that turn green? All right, so I go ahead and I get 2 times 1, that's 2, minus 1 to the third is 1 times 2, so you have 2/3, minus, and in here I have negative 2, negative 1 to the third is negative 1 times this negative 2 here, so that's going to be plus 2/3. And then I'll go ahead and distribute the negative. And that's going to equal 2 plus 2 is 4, negative 2/3, and negative 2/3 is negative 4/3. So I'm going to change. I'm going to change this 4 to 12/3. So that'll be 12/3 minus 4/3 for the area. And then that ends up being 8/3. And that's your answer right there. So those are a couple problems on finding the area that's found between curves. If you have any questions, please contact your math teacher and be great.